think we should be live. बोल दे भाई check.
Check, check, check.
All right, we are live. Let me do one last thing. So that our chat is visible to us all the time. All right. So this is day 37 of doing OpenUSD certification. We have completed 5 modules, and we are about to complete the sixth one. And we did asset structure principles and content aggregation yesterday. We initiated that module. We completed the overview setup, and then we covered the principles of asset structure, and we covered what are work streams, and we saw some practical examples for both of these concepts in exercises in our OpenUSD repository. And then today we are going to be focusing on completing the rest of the module, which is going to contain asset parameterization, reference and payload pattern, and model hierarchy. So a lot of fun stuff coming up. So let's get started. Asset parameterization. In this lesson, you'll learn about asset parameterization in OpenUSD, which enables the reuse of content by allowing certain fields and properties to vary downstream. Here we'll explain the purpose and benefits of asset parameterization in OpenUSD, differentiate between variants and prim bars as parameterization methods, organize our assets. Okay, and then this is the outline of the lesson. What is asset parameterization, and then the exercise covering asset parameterization. All right. So what is asset parameterization?
Okay,
Asset, as we already know,
asset.
a named resource that is maintained and reused. Yeah, go ahead.
Oh, I was just looking at the trippy colors, blue, gray, and all those assets
Yeah.
are getting reference over there. So I was gonna say that, but carry on.
Okay. So, asset parameterization enables the reuse of content by allowing certain fields and properties to vary downstream. There are two primary ways to parameterize assets: variant sets and primvars. Primvar, we already know, is a primitive variable, which is a special kind of attribute that can vary and interpolate across geometric primitives. Okay. There are two primary ways to parameterize assets: variant sets and primvars. So variant sets. The entry point, so this is a variant set, and then we can basically define on the prim what variant do we want for this primitive. So over here they have set the value for variant sets as color variant, and over here they have defined what the color variant should look like. So the entry point in is the place a user goes to determine if prims have discrete variants. Asset structure may enforce naming conventions and require the presence of specific variants. For example, it might be expected that assets provide a color variant to describe supported albedo variations. I don't know what this is, albedo variations. You are mute, bro.
I think it's a new terminology. It's, I'm looking it up. Albedo, base color for the same asset, means different base color for look for the same asset. Like basically, what do we have above over there? Asset
Mm-hmm.
01. So we have different base color, right? Blue, whatever this color is, orange, and then gray, and then for the same asset, we can have multiple colors.
Mm-hmm.
That is what albedo variation is.
I
Without,
see.
and the most important thing is without changing the underlying geometry. So we are basically gonna play with colors only, like the display color. How is it gonna be represented when you're trying to render it in a scene,
Mm-hmm.
right? Without changing any geometry. Yeah, that's what
Mm-hmm.
are albedo variations.
Mm-hmm. It might be expected that assets provide a color variant to describe supported albedo variations. Okay. So prim bars. Def Exform race car, color 3F, prim bars, acid base color, dock equals to primary paint color, dock equal to accent strip. Okay. Acid accent color. Okay. Some variations cannot be effectively or efficiently discretized
Into variants.
into variants. For these cases, primevars can be used as another form of asset parameterization.
Ah.
Yeah, primevars are extra parameters that can be interpolated and are primarily used to describe additional data for shading contexts. Okay, in OpenUSD, primvars are inherited down the prim hierarchy and can be authored on an ancestor prim, including the entry of point of an asset. In OpenUSD, primvars are inherited down the prim hierarchy and can be authored on an ancestor prim, including the entry of an entry point of an asset. Okay. I'm just gonna open prim bars over here on the side
Mm-hmm.
since
Mm-hmm.
this was a little complicated. Attribute blah blah. The need to bind. Oh, can I play this video real quick?
Yeah. 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 Yeah.
Hmm. So okay, um, when we are defining the color on a vertex, are we defining the color by specifying a particular primvar for that vertex?
It depends. So, like as it said, like if you go back into, if you uh, go back into the same asset parameterization, let's say.
Mm-hmm.
So if you go over there, it depends upon what kind of asset you're
Okay.
dealing with. That is the most important thing over there. So I would say if you're dealing with a complex asset where changing colors or doing something is really difficult, then we go with prim math. Like it gives you much more. I think it will give you much more accessibility when you're trying to change different type of things. So I think in this example, what we are doing, we are trying to use do multiple things, right? One
Mhm.
of the properties of primware, as I do remember, is primware can help you interpolate on different vertices,
Yeah.
spaces, and maybe have uniform distribution, right?
Mhm.
For example, can you go down? I think we can see an example right down. Go down.
Yeah, this is the example, right?
Like the output of it, output. So, yeah, this output, right? So,
This is full phase, this is half, and this
scenario,
is vertex.
let's say we change this and imagine there is a car, right?
Mhm.
If we use primware, we can basically paint and shade each and every door of that car,
Mhm.
right? But if we use variant sets, that painting and all those change of colors would be global, will always be uniform, right? But if we do primwares, it's going to give you more control over each and every component of that asset, like small frames. That okay, how will be the, what I would say, how will be the paint at this frame or at this point coordinate in that asset frame. Like, you remember u comma b, the mesh material thing.
Mhm.
On a mesh material, you can have multiple points of contacts, because a mesh is divided into grid,
Mhm.
right? So you can have two at 2 comma 3, or at a specific coordinate that we have, you can have a specific color, and then you can change
Mhm.
the color accordingly over the whole mesh network. But if
Mhm.
you use variant sets, I think you won't be able to do that kind of interpolation. Rather than, you will have like a solid color that is spreaded across the whole asset.
Mhm.
So, for example, the best analogy would be over here is, let's say you're trying to change a color on your site, right?
Mhm.
You can set a global color of your website as black, but now,
Mhm.
or sorry, global color for text as black. That is variant set,
Mhm.
right? You can say that in dark
Mhm.
mode, the color of a text would be black, sorry, white,
Mhm.
and black in bright mode, that is white mode. The color of
Mhm.
text would be black. So this, what in USD, this will be variant set analogy. But now,
Mhm.
what primvars give you is basically to set the color of each and every individual component. So you can have a header section, you can have a footer section, right? So you can define,
Mhm.
in header, all the text color would be blue, right? So that is more of an interpolation in comparison with primvars. And if you do like global settings, that will be more like variant sets. That's what my understanding is as of now, based on whatever we have seen.
Okay.
Yeah.
Mhm. Let me finish this. Mm. Got it. Mhm. Okay, we can go back to this now. Some variations cannot be effectively or efficiently discretized.
into variants. That's what it is saying over
Yeah,
here. That, for
for
example,
these.
you cannot set variants on each and every freaking thing that you want, because it's gonna mess up the way you want to
Mm-hmm.
interpolate it.
Mm-hmm. Mm-hmm. Okay. Okay. Primers are extra parameters that can be interpolated and primarily used to provide additional data to shading contexts. In OpenUSD, primers are inherited down the prim hierarchy and can be authored on an ancestor prim, including the entry point of an asset. Okay. Um. Okay. Primers, blah blah blah. In OpenUSD, primers are inherited down the prim hierarchy and can be authored. Uh-huh. Okay. Take for example the snippet above. Materials can be constructed and read. Prim vars asset base color. Prim var colon asset base color or other entry point if prim vars entry point prim vars if multiple prims in a hierarchy author the same prim var. Remember the child opinion are stronger than parent opinion. We use asset as prefix to avoid namespace collisions. Exterior color, primer, exterior current fight. Oh, sorry. Exterior type variant. Accent color primer and exterior type variant. Unless explicitly documented and not annotated. So give me 2 minutes.
Okay.
All right. Ah, so we took an example of the above snippet. Materials can be constructed to read primvares, acid-base color, or other entry point primvares. If multiple prims in hierarchy author the same primvar, remember that child opinions are stronger than parents. We use asset as a prefix to avoid namespace collisions. Okay. Unless explicitly documented or annotated as internal variants and primvars authored on an asset entry point should generally be considered public. hmm And safe for downstream context to edit and set, with an expectation of stability. hmm You got that? Yo.
Yeah, yeah, I got it. I got it.
Okay.
Both,
So
yeah, both variant selection and primvars on the asset entry point are compatible with scene graph instancing. What is scene graph instancing again?
I think it is this you see this
Yeah,
list.
that
That
is
is the
that is more of a relationship thing. It's not scene graph instancing.
that wait, I'll show you this oh oh bro, that is amazing. Look at this.
Payload can be load and unload crazy shit. Ducks farm. Oh yeah, it's more for relationships. References. Okay, references. Yes, yes. Okay, okay, got it, got it. Yeah.
Or wait, bro, I didn't see this. Oh, specifier over. Ah. Composition arcs include sublayer inherits. Layer can have sublayer forms, prim spec, direct opinion. Damn, bro. Stage population. Hmm. Value resolution, rendering, path translation. Oh, damn, this is amazing. Def class, direct opinion. Okay, model group aspect. Okay. Oof, interactive glossary. Okay. Okay. Yeah, this generally makes parameterization through primvars the lighter choice for single property parameter, offering upfront memory savings at the cost of additional lookups in material. So, what is this example showing exactly? Light on 2, 3, 4, 1, 3, 5, 8 practical lights. So relative rel.
Relationship. I think that's more for relationships, not relative. It's for
Okay.
relationships.
Relationships, user properties, practical lights,
I got it. I got it. I got it.
block
Yeah, you
block one lights,
remember
light
we
one.
did created a cube like in our one of our I think earlier uh, how would I say notebook. We created
Mm-hmm.
cubes that had same type of assets getting loaded, but the naming was different,
Mm-hmm.
right? Like I think we were loading something I don't remember. I think yeah, it was lights only. Like there was a 3D scene, and then you're
Mm-hmm.
referencing multiple light poles in that scene,
Mm-hmm.
right? Like and then in that scenario. So over here, light one, light three, light five, light eight, whatever we have are basically smaller prims that are
Mm-hmm.
loading or referencing the same component again and again, right?
Mm-hmm.
They are getting loaded into different prims.
Mm-hmm.
Over here to save on memory, I think
Mm-hmm.
we'll be using scene that what it said over here. Scene, where does it say? It did say something. Scene graph instancing, right?
Mm-hmm.
This is where scene graph instancing kicks in. So when you create relationships towards your other asset files that have these components, such as light three, such as these lights that are shadowing down uh,
Mm-hmm.
on the road, basically. When you do create relationships, you can put instanceable true when you're referencing.
Mm-hmm.
And when as soon as you do that, you have created a shared memory buffer that is pointing
Mm-hmm.
to the same memory in your chip or wherever
Mm-hmm.
it is, so that
Mm-hmm.
you don't have to re-render or you don't have to load your memory again and again with the
Mm-hmm.
same asset. That this is what is happening over here, I would say.
Mm. I see. So collections as a part of asset prim interface, collections and relationships can be used to indicate the membership and roles of certain prims. Consider a workflow centered around practical lights. By highlighting these practical lights in a collection at the asset entry point, it becomes easier for user to find and interact with them downstream. Hmm. You can group important parts of your model like lamps into labeled collection at the very top of your file. This acts as a quick access shortcut for any other artist using your models further down the pipeline. Bro, I'm a little confused with the usage of Prembar over here. Okay. Primvar is a type of attribute, and primvar has interpolation. Hmm. She told me her name is Billie Jean, and you guys have seen. A primvar is a special kind of attribute that is a variable. Primvar is you work with primvars through USD Geom Imageable and USD Geom Primvar. With all primvars using primvars namespace prefix. Hmm. Primvar OpenUSD or I don't think I need to do that. Okay. Renderman. Computer geometry prim that the rendering slash shading pipeline is meant to consume. Mechanically, it's just a USD attribute living under the primvars namespace, but it gains two powers plain attribute doesn't have. Those two powers are interpolation uh, across surface. A primvar carries a value per geometric element, per point, per face corner, plus interpolation metadata, telling the renderer how to spend those values over the surface between the elements. Okay, inheritance down namespace. A constant primbar authored on an ancestor prim is inherited by all descendant geometry primbar author. So plain attribute is data sitting on a prim, and primbar is the data renderer shade can bind to interpolate over geometry and inherit down the hierarchy. The primbar namespace plus interpolation modes. The full attribute name is prefixed. Example primbar display color primbar st UVs. The interpolation metadata is the key norm. It says how many values you provide and how they map on to the topology. Constant one value of the entire G prim. These are the ones that inherit down namespace, one value per face. Okay, I think this is what we did over there as well. Mm, in the code that we had, one value for the entire G prim. These are the ones that inherit down namespace, one value per face. Varying one value per point interpolated linearly across faces, vertex one value per point interpolated. Okay, USD example. So where the vertex versus face varying distinction is one that traps people. Vertex is the one value per point, continuous face varying. Values be discontinuous across an edge needed for UV islands and hard edges. Index primvars are an optimization. Store a small array of unique values plus an indices array mapping each element to one of them and an index buffer exactly deduplicate UVs. Def mesh quad def mesh quad 0.3f points equal to -1 0 -1 1 0 -1 101. Okay. Color 3f primary display color interpolation equal to vortex. Texture quads face varying plus indexed. Interpolation equals to face varying. Int primvars st indices. Defx form group constant primvar on the parent inherited by descendant gprims. String primvars render tag beauty. Interpolation equals to constant. What is going on here? But primvars, I still don't get it. What primvars is doing exactly? I don't understand.
Like, ask and explain it to a 10-year-old. What else you can do there?
No, in the code, I'm trying to understand. I know what it's doing, but interpolation is equal to vertex. So primvars display color over here. Color 3F primvars display color interpolated across the surface. Primvars st primvars render tag. What? You pass the name without the primvar prefix. API adds it. The dominant real world uses feeding shaders via primvar reader. Dominant real world is feeding shaders via a primvar reader. A material network doesn't read geometry attributes directly, it pulls a named firmware off the bound mesh through USD firmware reader node. I fucking don't understand this. Quick decision rule E reach for firmware when the data must.
Not able to.
What?
What is the part you are not able to understand?
Like, what is it used for? I don't understand what is it used for. Like, what?
What is
So
the
we saw the
what
what
is
is okay. Wait. We saw the example. We saw three different
yeah,
faces, like where one was completely purple,
yeah,
and then there was two different colors in
yeah,
the two faces, and then there were gradients, right?
yeah.
So, what's the use of primvars over there? If we are like,
So
that's what
I
I'm
said you again.
asking.
I said you again. Like, okay, you are looking at a 2D form, right? That's a two-dimensional one. Now, first of all,
Mhm.
what is a mesh? Tell me that.
Mesh is like the property of the material.
Oh, literally, what is mesh? What is mesh?
I don't. What is mesh?
Yeah, what
It's
is a mesh?
what is a mesh? Characteristic.
Yes, okay, mesh. Okay, what characteristics that mesh has? Like, if you take a mesh network or a mesh
Mm-hmm.
or
Mm-hmm.
something, and you wrap it around an
Mm-hmm.
asset, a 3D
Mm-hmm.
asset. Let's say you have this bottle, right?
Yeah.
And you wrap a paper or some
Mm-hmm.
kind of thing, right?
Mm-hmm.
So if you go if you let right if you go to Google, can you open
Mm-hmm.
Google? Yeah, and just type mesh 3D mesh 3D. Yeah, enter. Go to images. Yeah, okay, yeah, this is the perfect one. Go, yeah, just pick up any example you want, rabbit or dolphin, whatever you want, whatever you like.
Okay. Like this one. Hmm.
Just open it up, right? Yeah, like make it bigger. Do just open the image,
Yeah.
right? Okay, we are gonna go with this, right? Now,
Mm-hmm.
when you look at this mesh, what you can see? How will you identify a patch?
A path.
A patch.
A patch.
Yes,
Oh, like this.
yes. How will you
Mm-hmm.
identify it?
By getting the coordinates of
Yeah.
the
Once you
points.
got the coordinates, what can you infer to as a vertex at this point,
Yeah.
right?
Yeah.
Now you have the vertex and the coordinate. Can you say it's a phase now,
Yeah.
right? Now once you have this, now you what you can do is you can map these vertices
Mm-hmm.
across. Let's say if you take a U, like let's take the whole mesh that is around his neck,
Mm-hmm.
right?
This.
Yeah, this whole neck. Right. Now you
Mm-hmm.
know all the coordinates of this mesh, right?
Mm-hmm.
Now what you can do is you can interpolate by using either vertices or a uniform distribution that hey, you will be giving some set of coordinates as we gave in the primware example, right?
Mm-hmm.
Now the coordinates will be more complex, but I'm just explaining you with an example. right?
Mm-hmm.
Now once you do that, you can say, hey, how will it be interpolated when you try to apply a color or something? Right. You have multiple options. First is across vertices, right?
Mm-hmm.
You are only gonna pick up the vertices and color something over there.
Mm-hmm.
Or either you can do uniform. So you can say that, okay, I'm gonna pick up the coordinates from shoulder to shoulder and in this
Mm-hmm.
range, and I'm gonna uniformly paint them red. So what you will
Mm-hmm.
have is a whole complete mesh of red color when you do uniform.
Mm-hmm.
Are you getting it or not?
Yeah.
Right? And similarly, now when you do this, you can
Mm-hmm.
map it to different groups. That's what it's
Mm-hmm.
saying. So you can say that this is gonna be a neck grouping. That what
Mm-hmm.
necklace, right? We will say prim vars necklace.
Mm-hmm.
And we
Mm-hmm.
know what are the coordinates that stands under this necklace. Right? So
Oh.
then it's a mesh. And that mesh can be wrapped with a material. That material can be anything that you want, a color, a
Mm-hmm.
fabric, whatever you want. So that's what mesh is. And then how do you want to interpolate? How will you find whatever exists on that mesh? Is by
Mm-hmm.
finding the coordinates. That hey, these are the
Mm-hmm.
coordinates, and these are the coordinates that we are going to select across all the axes to maybe
Mm-hmm.
define this is going to be the color, or this is going.
So wait, okay, wait. So over here for def mesh quad, right?
Yeah.
We are doing these points for the indices,
Yes.
right? One, two, three, four.
All of them are
Zero, one,
adjacent
two, three.
indices. If you
What?
notice that all of them are adjacent.
Yeah, adjacent.
Yeah.
And then we do color 3F.
Yes.
So pre-vertex color interpolated across the surface. So what is exactly this doing? So color 3F and then primvas colon display color.
Yes. So this is one of the property that you're trying to create over here. That primvar and display color. So primvar is the primvars asset parameterization value thing that you're gonna pick up, one of the properties we have, and
Yeah,
then
but like what is this doing here? Like I
it's
know what is
grouping it.
this doing.
It's grouping it. So whenever you will pick up primvars display color, it will auto pick up this interpolation you have.
Mm-hmm.
Right? That's only namespacing. It's not a function. It's nothing else. It's only a namespace.
Mm-hmm.
You are grouping it in a display color thing. It can be
Mm-hmm.
anything. It can be display color vertex. It can be display
Mm-hmm.
color face.
Mm-hmm.
That's what it is doing over there.
And how is that different? So primvas display color,
Yeah.
colon display color, and then over here it is doing primvars ST. How
Yeah.
is this different?
So that is only doing interpolation. Look at the interpolation value over there. What is
Yeah, so this is different, right?
yes,
Interpolation equal to vertex and interpolation equal to face varying.
yes.
But what if I did primvas display color and interpolation equal to face varying? What will that do?
It's gonna do interpolation with face varying. That
So
is
what is the point of changing the namespace over here?
it's for developer. Let's say you have a developer that is gonna work on assets, right? And
Mm-hmm.
how will you know that which grouping to select when you're trying to do something? So assume that this is a preset, right? There is a preset in your asset that helps you select some primware properties that you have
Mm-hmm.
already created. It's like more of a naming convention, right?
Mm.
So like we have variant sets, right? So in that you can do variant select red. So what will that do is it's going to select the red color on that
Mm-hmm.
asset, right? Because that is one of the property we have. Now you if you want more, if you want to give more flexibility, more power over the asset, like on
Mm-hmm.
each and every mesh material you have, right? You
Mm-hmm.
do with prim vars. So now when you're trying to import this, so if you go back, not over here in the other example we have, like you can create a grouping over here as it says, like in the asset parameterizations,
Mm-hmm.
right?
Yeah.
Over here, what you are trying to do, it says user properties, practical lights.
Mm-hmm.
right? Primware asset base color. So you're just selecting that this is going to be the asset base color, and this is one of the properties that it will
Mm-hmm.
have, right? That is how you are selecting. So now if you select primware asset accent color, it's gonna
Mm-hmm.
select color of accent strip,
Mm-hmm.
right? So over here, this is more of a low level example, but if you add more properties into that, let's say you are saying that in this there is going to be some kind of interpolation, there's going to be some kind
Mm-hmm.
of other things like the coordinates we selected. So now
Mm-hmm.
when you select primware asset accent color, it's going to do
Mm-hmm.
changes across, or it's going to pick up all the changes that is being across that mesh network that we have
Mm-hmm.
selected as I showed you in that example. That's what primware, it's more of a grouping that, hey, you want to group some certain set of things. How will you select a certain area in your bigger mesh network? One of the
Mm-hmm.
way is to select a set of coordinates, adjacent coordinates that you want to do, and then you define that, hey, let's say primware's necklace. So you are just selecting the area under the neck, right? And then you can apply your opinions. Hey, I want to maybe change the color to red or do something else
Mm-hmm.
on this primware. So you can maybe do it on a higher level that maybe there is a property for colors that you can override into it.
Mm-hmm.
That will be the one of the opinion for that primware. Since what are prims? Prims are object containing your assets, right? So you can definitely override a prim with another opinion by overriding the accent color that you want.
I
And
see.
use asset underscore as a prefix to avoid namespace collisions.
Mm-hmm.
That this is one of the standardized way to use primvars. Right, so primvars is a way to declare that this is an asset property or a asset parameterization value, where you can add extra parameters to your asset that you want to work on with. See, it says over here that primvars are extra parameters that can be interpolated and are primarily used to provide additional data to shading contexts, right? As I showed you that, okay, if you want to select a patch, you will use primvars. How will you select it?
Mm-hmm.
If you want to do a complex, like there is a really complex animation that is going on, or there is one of the better example is, let's say you want to do an animation where a bird is trying to fly, and there's an animation look where the bird is trying to flap its wing, and you want
Mm-hmm.
to, as the bird flaps its wing,
Mm-hmm.
you want to give an aura, right?
Mm-hmm.
You want to give an aura. So what you can do is you can select the coordinates around the bird's wing, and then just
Mm-hmm.
every time animation, like let's say
Mm-hmm.
around 10th frame,
Mm-hmm.
the color or the aura of that bird changes to green
Mm-hmm.
on only certain specific area, not the whole color, not the whole wingspan, but only on the edges. But how
Mm-hmm.
can you do that? By wrapping it in a mesh and then just interpolating over the points that you have,
Mm-hmm.
right? That's why if you are using variant sets, like if you go above,
Mm-hmm.
like on the top a bit out. Yes, so in variant sets over here, as you can see, you can only change the color of the whole asset.
Yeah.
But when you want to just change the color of a smaller part of the asset,
Mm-hmm.
you will use primvars because it provides you with the property of interpolation across a
Mm-hmm.
specific coordinate or something that you want to do.
Mm-hmm.
Right, that is the most important property over here with prim.
Got it.
Yeah.
Oh, so basically in a cube, if I am like, so for variant sets, the property will be applied to the whole cube, and with primvars,
You can
I
select.
can
You can
basically
select. You can select.
different points on
Yes.
the cube to define the
You can
property
select the
of those particular
grid,
points.
smallest grid. Like let's say your cube has 200 set of faces, right?
Mm-hmm.
So you can have individual set of colors for each of those.
Mm-hmm.
You can take an example of Rubik's cube. If you wrap
Mm-hmm.
Rubik's cube into a mesh network, then you can have all the small cubes, right? That is
Mm-hmm.
going to be interpolation, and then you can select each face. So on a Rubik's cube, you can have 1, 2, 3, 4, 5, 6, right? 6 into 3, 18. 18 faces on a single side. Sorry, 9 faces on a single side,
Mm-hmm.
right? Those
Yeah.
9 faces can have you can have and on the adjacent side of those cubes, you can have other 9 faces, right? So you can
Mm-hmm.
just basically select that, okay, these faces, on the first 9 faces, the color should be red, blue, green, and accordingly, and then you can interpolate it across different faces, right? So
Mm-hmm.
this gives you more of a property. But now let's say you don't want to use
More control on the property of smaller parts of a particular prim.
Yes, yes, more. Yes, yes.
Yeah.
That would be the most appropriate or accurate way to describe it. And now, if
Mhm.
you, what do you don't now you are like, no, no, I don't give a shit. I want the whole cube to be black. So you
So I'll just put a variant set
gradient
and
set
set
and
it
you
to
just say
black.
black, and now you
Yeah.
want the whole cube to be red. So it's more like if you're trying to buy a Honda
Mm-hmm.
or
Okay, got it.
a normal car, you can have normal colors. But if you buy a premium car, you get a much more high level of detailing as compared to variant sets or a local car.
Got it. I understood the utility now. So I'll just read this one more time. Unless explicitly documented, okay, some variations cannot be effectively or efficiently discretized into variants. For these cases, primvars can be used as another form of asset parameterization. Are extra parameters that can be interpolated and are primarily used to provide additional data to shading context. In OpenUSD, primvars are inherited down the prim hierarchy and can be authored on an ancestral prim, including the entry point of an asset. Take an example, the snippet above. Materials can be constructed to read primvars, acid base color, okay, or other entry point primvars. If multiple prims in hierarchy author the same primvar. If multiple prims in the same hierarchy, in a hierarchy author the same primvar, remember that child opinions are stronger than parents. We use asset as a prefix to avoid namespace collisions. Hmm. If multiple prim in a hierarchy author the same primvar, where that child opinions are stronger than parent.
And let's see what does it mean, because it corroborates with the composition arc property we have.
This one.
Yeah, how can child opinions are stronger than parents? That is really confusing over here.
If multiple prims in hierarchy, unless explicitly documented or annotated as internal variants and primvars authored on a certain tree, point should generally be considered public and safe for downstream context to edit and set with an expectation of stability. Hmm. Okay, using a car example. There are two separate concepts happening in this code: hierarchical overrides, who wins a disagreement, and namespace collision,
Oh,
actually
okay,
using the
okay.
same weight. In OpenUSD, so child opinions are stronger than parents. In OpenUSD, if you apply primvar to a parent folder like an XForm, it acts as a blanket rule that trickles down to everything inside it. However, if a specific child object inside that folder has its opinion about that exact same primvar, the child specific rule always wins. Yes, I know that. Okay. Imagine you have a car parent and it has four tires, children's. You author primvar display color equal to red on parent car. Okay. Because the trickle down effect, the doors and the hoods and the tires turn red. But wait, the tire shouldn't be red. You go directly to the tire meshes, the children and the author primvar display color black. The result, the car stays red, but the tires turn red. The child's specific opinion is stronger than the parent's blanket rule. We use acid as a prefix to avoid namespace collisions. Okay. Use acid as a prefix to avoid namespace collisions. Hmm. When naming custom view accidentally. So, okay, now if I take a look at this example, what is going on over here is, so we have a mesh called quad. It has vertex counts for like face four faces. It has four indices. The points of these indices are this coordinates per vertex color interpolated across the surface. So color 3F prim as display color, and then interpolation is vertex. So what this is doing is setting the color on each face, I guess. Right. Texture codes, face varying plus indexed. Text code 2F prim bars ST. Interpolation, face varying. And then int prim bars ST indices. What is this doing? This usage with a very simple. Okay, let's do it. Okay, we can. I think we'll be more clear in the exercise, I guess.
Yeah.
Okay, in this exercise, you'll create a prim var as an asset parameter to control the accent color of the building's awning. What does this mean? This documentation has a lot of stupid words for no reason. A roof-like secondary covering attached to the exterior wall of the building. Oh, this is an awning. Do you get it?
Oh, I see.
Okay. Note that we have updated large building F assets, so the roof material now accepts a primware for its diffuse color. In Visual Studio Code, open the following file: USD shading dot USD contents. Okay. So over here we have over world. We have two scopes, def scope looks, and then we just have one, and then we have over geometry. Uh, mhm, uh, uh. Hmm. So what do they want us to do? Find the following snippet: def shader, prim bar, accent color. Uh, okay, this is the accent color, prim bar accent color. Mm-hmm. This material graph now uses USD primware reader float 3 to read primware called U primware's accent color. USD reader float 3 uniform token. Bro, I have no idea what this fucking uniform token shit does and why is this info ID and all that shit. Brother, you are muted.
Go back and look at the example in the prim var. So you will see it over there. Uniform. It's gonna make the color uniform across the whole face. Whatever you are selecting.
And token?
That is the API that you use.
Token.
We had uniform dot token, right? So we are selecting
Hmm.
uniform token. So, but the most important just over here is what is the option over here that we are going to select. So by default, that token is gonna be inside the API. I would say.
Hmm. Float 3 inputs fallback. Blah blah blah. Okay, let me see. Here is the simplest possible picture of what Primware actually does. Take one flat square, a single quad face, and put the color Primware on it. The only thing that changes between these two squares is interpolation metadata, same attribute, same prim. Bro, why is Cloud fucking okay? Constant vertex.
You're gonna ask him for a similar example for uniform as well, and you will get it.
Okay. The reader node names the primware, the renderer fetches it off the bound mesh, interpolated exactly as the picture shows. Oh, here it is. Uniform token ID. USD primware reader float 3. So the primware is where the data lives on the geometry. Interpolation is how it spreads across the surface, and the primware reader is how material pulls it in. UE's primware ST works the exact same way. They're just float 2. Okay. Yeah. By float 2 values per corner instead of colors read by a USD primware reader float 2. Mm-hmm. Mm-hmm. So what do they want us to do in this? This material graph now uses USD primware reader float 3 to read primware called primware's accent color. Okay. Where is the primware accent color over here used? We are just seeing accent color over here, but we are not seeing primware accent color.
What do you mean we are not seeing primware accent color? Wait.
So over here, it's saying string inputs var name
Yeah.
accent color, right? And then, okay, so the shader name is primware accent color.
That's a namespace for that shader.
Okay. Namespace, this
Yes.
one.
Yes, this is a namespace. Like this is a
Yeah.
naming. When you want to refer it into
Uh-huh.
some other asset file that you're trying to import or any other USD file, this is what you use to
Mm-hmm.
reference, because shader is a type that, hey, this is a shader definition. More shader is like a function type. Okay, this is what this function is supposed to do. And what is the namespace and how do you name it? You're gonna use primvar accent color to call it into that thing. So let's say you are trying to call primvars colon prim accent color. So it's gonna load all the properties of that grouping that you have. That is gonna be uniform token that uses prim var underscore float 3, the fallbacks, the var name, that is accent color, and the output result. What is the output result gonna be in? And it's gonna be in float 3.
Mm-hmm. Float 3 is what?
Float 3 is a data type. Double,
Float.
float.
I know, like decimal flow, like
Yeah, so float 3, why? Because we are taking 0.33, like a bigger d-
decimal value.
decimal value, a bit bigger decimal value, right? So it can have a bigger memory buffer, right? So this is directly referenced with C++. In C++, when you're trying to store something in the memory, you need to define what is the type of data type and how big the memory is gonna be. So for float, the size is gonna be different. I don't remember it thoroughly. For double, the size of the memory buffer is gonna be different. I think it's gonna be 8 byte. For float, it's gonna be 16 or 32 bytes, right?
Mm-hmm.
And then if you have something bigger than that, oh, that like for if you have only integer, then it's gonna be a 32-bit integer, right? And
Mm-hmm.
that is the maximum size of it. But for a float, it can be anything in 10 values. Like it has a really bigger buffer byte as compared to a double or a normal integer value. If you're gonna go with that.
Okay. So I understand this now a little bit,
Mhm.
primvars. So we are not naming anything over here. It's just we are going to
Yeah,
be
we just named prim var accent color.
okay with a fallback color. If it does not find primvar, the input's fallback is the green color we saw previously for the roof. Let's explore what happens when we author primvars accent color in Visual Studio Code. Open create asset parameter dot py. Okay, and then what is this doing? So this is setting the color to red, I guess. Accent color dot set. In the code, we are creating the primvar using the primvars API and setting the color to red. Okay. Default prim is USD dot prim equals to stage dot get default prim. What would be the default prim over here and why?
Where would the default prim would be defined prim? Do we have any default prim defined? No. There's going to
No,
be no default prim first of all. Why? Because this is
but
a
it is trying to get the default prim though. from this
No,
file.
so it is not trying to get the default from this file. You are looking at the wrong file.
Oh yeah, this one, this one.
That is a default prim.
So world over here,
Yeah.
and then it's going to.
Yeah.
Mm-hmm. It's going to go to shading and geometry. Okay. Primvar's API is equal to USD geom dot primvar's API of default prim. So what is this line doing exactly?
Which line? Line 24 or line 25?
24. Primvar's API equals to USD geom dot primvar's API at default prim.
So we are basically assigning prim as
Binding.
API onto that default prim. Like we are
What
letting.
does that mean? What does that mean?
So it means
Assigning
that we are
API to
defining
that
the entry
default prim.
point for that primware. That okay, this is the prim we are gonna play with. This is the entry point of that primware.
I
It's
see.
yeah. That okay. How will you know? How will you tell your primware's API? If you want to do more transformations, if you want to play more with your prim that you have, how will you define that? So you're gonna use that to define it out there.
Mm-hmm. Mm-hmm. It wraps default prim in the primvare's API helper, giving you the interface to create and manage primvares on that prim. I see. The next lines use it to author an accent color primvare. Mm. The next lines use it to author an accent color primvare. So this line is just the gateway to that functionality. Okay, I see. Okay, and then so this is wrapped. Accent color equals to primvar underscore API dot create primvar accent color SDF dot value type names dot float 3 USD geom dot tokens dot constant. The accent color is set to 100. So I think this should change over here once we run this, right? This should become 100.
Yes.
Python create copy path. Let us see. What did it do? It didn't do anything.
What? Why is it gonna do over there?
Oh, so it's just gonna add like a local opinion for primvar.
Yeah. We never
Oh,
do
inside this.
changes it directly. Like that would be destructive, right? Since playing with the
Oh,
prototype.
that might belong to somebody else
Yeah.
in the layer.
Yeah. So you will do is you will do it
I
in.
see. Hmm.
So like for example, somebody else is trying to use the same shader file, and you're trying to git push it, then it's gonna mess up their shading.usd accordingly, and then whatever image they had also be messed up.
So now if we run, I guess. We got it. So roof, timber accent color 100. The shader is 100. Okay. World looks roof. Hmm. World dot primavera accent color. I see. Okay, I think I understand this a little bit now.
Yes, sir.
At a first glance, we can see that the roof is now red when selecting the roof from the tree view, then selecting accent color. In the property panel, you can observe the metadata panel that the accent color is being generated down the prim hierarchy from the asset parameter we created rather than from the USD primware reader is fallback value, the I symbol next to the attribute. Where is the I symbol? The I symbol next to the attribute name indicates that it is an inherited property. Where is the I symbol? I don't see the I symbol.
Wait, what I symbol are you talking about?
This, look at this.
That it is I think.
Oh, I see, I found it.
Oh, it's over
I
here.
found it.
Yeah.
Yeah, look at this. I,
It's
it's
inherited, right? Or what?
yeah, inherited.
Yeah, makes sense.
Inherited property. Reference payload pattern. Look at this. I think I do understand this, but the fuck, bro? Why is it? It's gonna take some practice. I mean, I can answer questions now, but
I think as we go more deeper and look at more examples and hands-on experience, yeah,
yeah.
there are still some gaps, gaping holes in our reasoning and understanding.
Hmm.
Yeah, that will be covered eventually.
Yeah.
Reference payload pattern.
Bro, give me 1 minute. Fuck. This is heavy. I'm gonna be back in 1 minute. All right, we can quickly read this. I am just heating my umami truffle fries on the pan. So,
Right. In this lesson, we will learn about reference payload pattern in OpenUSD, a technique used to optimize asset structure and performance. By the end of this lesson, you will be able to explain the purpose and benefit of the reference payload pattern in asset structure, implement the reference payload pattern, explore the concept of lofting important fields about the payload. Here is the outline for this lesson. What is a reference payload pattern exercise, exercising the lofting primvaries, and then exercising lofting variance sets.
all right, they're preheating. Mhm. I really like this part. Prim may have a model kind, and model might assemble into model hierarchy. Asset info used with model. Group type of model. Component is a type of model. That I think that's what we're gonna see right now in the exercise as well. Oh, you can move them also. Damn, some crazy shit. Schema domains, geometry, rendering, miscellaneous schemas, model hierarchy. Hmm. Dude, my fries got a lot of moisture.
Moist, moist.
Yeah, so I
Shimoshi.
put them on a pan. Impress me, baby girl. Can you hear the music today as well?
No, not that much.
I see. All right. Hmm. Mm-mm-mm. Mhm. Yum. Truffle fries are good. Mm-mm, mm-mm, mm. All right. You want to start reading?
Let's go. What is reference and payload patterns? Instead of expecting user to know whether a complex asset requires payloading, many assets adopt reference payload pattern. This means the interface file is designed to be referenced with payload structure internal to the asset. Important and inexpensive fields are like variant sets, and inherited properties are elevated above payload when they are moved from contents layer to the interface layer. Lofting fields can help avoid the need to load a payload in certain contexts, thereby improving overall performance. Since there is no general utility for lofting, it is typically achieved through site or project specific post scripts associated with asset generation and publishing. Fields found in USD model and USD geo model API, such as extends hints, are good candidate for lofting. Wait, what is lofting over here? Did they explain?
Yeah, even I don't know.
Yeah, that's fine. That's fine. I think they're going to explain in the future. The USD geo models API provide a set of fields that can enable previewing of payload content before loading. Newer releases of OpenUSD have introduced the median asset preview API as a schema for describing asset thumbnails. By lofting fields, you are making functionality that was previously buried deep within the payload more accessible. This involves authoring new elements above payload, creating overarching variant sets that control lower variant sets, and defining attributes that a payload connects to. Essentially, you are always introducing a new field and maintaining accessibility of the functionality above payload. A lofty class does not contribute any opinion. It's just a target. It just provides a target for the something for the arc. Okay, so let's take a look at this. Now we have an X form, my asset. Then we have variant asset. Okay, string color variant. You have payload.
Payload.
Okay, all right. So we did loaded the payload.
Hmm.
Corporate variants do not contribute any opinions. They just advertise the sets and selections specified by the underlying contents. Okay, now then we have variant sets. That is going to be color variant. Then it's going to be red and blue. I don't know, man. Like this is. So we defined variant sets above, and then we defined the color. Oh, okay, okay. I think I got it. I got it a bit.
Wait, the lofted variants do not contribute any opinions.
Ugh.
They just advertise the sets and selections specified by underlying contents payload.
Okay, so I'm assuming over here is content.usd has some kind of variant sets
Mm-hmm.
already that exist in over there, or
Mm-hmm.
there is some kind of functionality that they accept these kind of variant sets.
Mm-hmm.
And in the above X form, we are just defining that this is going to be the variant sets and this is going to be the color of that variant set.
Mm-hmm.
That is what we're going to select.
Mm-hmm.
Right. That is my assumption as of now. The reference to the payload pattern can be used to recast a payload opinion ordering strength, while the above example uses an inline payload for brevity. If a
Mm-hmm.
mirroring resolver is issued, it becomes important to keep payload content in separate layers. Payload from reliability. Let's see. Let's see. Let me take a look over here. What the fuck are you doing?
Mm-hmm.
We are authoring which okay, we are at asset. Okay, okay, this one, reference and payload. Alright, alright, alright. Team, team, team. Next, next, next. First of all. Ooh, what is lofting? What is means involving author selected fields above a payload? Explain with a more elaborate example.
Okay. Payload is a composition arc as well, right?
Yes.
Mm-hmm.
Okay, so oh, okay, okay. Now I know what is lofting and what is this thing is
Explain easily
easily.
to a 10-year-old.
Yes. So assume you have a bottle,
Mm-hmm.
right? In that bottle, you put milk,
Hmm.
right? And that bottle is gonna be your contents.usd.
In the bottle that we poured milk, that is my content.usd
Yes.
container. Okay.
Yes. Now you can assume that the color of the milk can be anything, maybe
Mm-hmm.
pink, maybe red. That will be our variant sets.
Mm-hmm. Okay.
Right? Now in contents.usd, there were already variant sets defined,
Okay.
right?
Yeah.
But now what you're trying to do is now you have wrapped the you now you're looking at the bottle from a different view or through
Mm-hmm.
a different file. That's what we are seeing right now.
Mm-hmm.
right? We are trying to load that bottle into a different file.
Mhm. Mhm.
Now we already know that that bottle has some kind of variant sets that exist
Mhm. Mhm.
that will help you change the color, right? So
Mhm.
you have two options. Either you can define your opinions on
Mhm.
the variant sets and directly pass on to that layer,
Mhm.
or what you can do is you can define them in your main file. That is the file that
Mhm.
is loading that bottle of milk,
Mhm.
right? So what lofting does is lofting helps you define the variant set file variant sets directly into the
Mhm.
main file,
Mhm.
right? And with the help of that you can do all those changes directly over here rather than passing them on to the lower layer or overriding their opinions,
Mm.
right? So that's why it says lofting variants do not contribute any opinions. We are not contributing any
Mhm.
opinions, right?
Mhm.
We are just picking up those variant sets, right, and then defining them in our main file so that we can play with them directly over here.
Mhm.
That is the most major difference over here where lofting comes in. As it says, like
Mm.
if you look at, wait, I think it says over here, right, lofting fields can help to avoid the need to load a certain context. So let's take a look at this example that we have, and
Mhm.
like the above one, the image.
Mhm. Yeah.
So in the first image, you have variant sets in the contents.usd.
Mhm.
That is our bottle of milk. Over here, it's a car, but that's a bottle of milk.
Mhm. Mhm.
Now you will use lofting and pull those
Mhm.
variant sets into the root layer
Yeah.
from that contents.usd,
Yeah.
right? And
Mhm.
now on the third image, when you pull them directly onto the root layer, there
Mhm.
is no variant set in that contents.usd. So when you load
Yeah.
payload,
Mhm.
whatever the value you are trying to change will be first set, and then only that payload will be rendered.
Oh,
You know what I'm saying now,
a little bit, yeah.
right? So you can also take it as a terminology where you're trying to define a function in Python that
Mhm.
takes an input as something, let's say variant sets, and
Mhm.
it's gonna go set it in the file. But rather than you giving the option in the file, you can directly
Mhm.
pass on that specific value or that specific set, because what payload helps you to do? Payload
Mhm.
helps you to load and unload content based on your will,
Mhm.
right? So when you load a payload with different variant sets, what will happen? Let's say you have 1 million variant sets in a file,
Mhm.
and when you load that file, all those 1 million variant sets will be loaded. Am I right or not?
Mhm.
Because
Yeah.
that's payload file.
Yeah.
Now you are saying that, hey, I want to optimize this.
Mhm.
What is the best way to optimize this? Let's not load all those variant sets into that payload, and we
Mhm.
can bring up that variant set into the above file.
Mhm.
And when,
Just a few variant sets in the above file, in the root file.
yeah, and
Mhm.
and we are going to remove that variant set from that file as well, that
Mhm.
content.usd,
Yeah.
right? Otherwise, if you have that, then payload will also render those things, even though you are not rendering them, because that's
Mhm.
how payload works. Payload renders everything, because like when you use compose, when USD composes, it uses traversal and it's gonna go to the
Mhm.
last root layer,
Yeah.
last node that exists in that hierarchy.
Yeah. Yeah.
So for payload, what will be the last leaf nodes? That will be all the variant sets that exist.
Mhm.
So instead of that, you just pass on that variant set directly to the
Mhm.
payload with the payload
Mhm.
and only render that specific thing into that content.usd. So instead of loading all the 1 million points or all the 1 million variants, you
Mhm.
only load only one variant that you're trying to define. That is white milk,
Mhm.
pink milk, or whatever you want.
Mhm. Okay.
Yeah, that's what lofting is. That you pick up. You basically remove the your variant sets from your payload onto the root layer file,
Yeah.
and it's not contributing any opinions. Why? Because it's removing or
Mm-hmm.
offloading variant sets from the main file. So now the original file that we are trying to load as payload doesn't have any opinion that exists. Whatever
Uh-huh.
exists is on this file only. That is the lofted class file or the lofted one.
Oh, so this becomes a because this was a lofted variant set.
Yes.
This becomes a local opinion,
Yes.
and
Yes.
this becomes the one that is being used for the prim's property.
Yes.
Mm.
Like it's not even an opinion. It's like a definition that okay, this is what we're going to pass directly.
Mm-hmm. Okay, let me read this again. I think I can understand this now. So lofting fields can help avoid the need to load or payload a payload in certain contexts, thereby improving overall performance. Since there is no general utility for lofting, it is typically achieved through site or project specific postscripts associated with asset generation and publishing. Fields found in the USD model API and USD Geom model API, such as extents hit, are good candidates for lofting. Okay. So these functions are basically just pulling the variant sets from the payload to the root file. I guess this function extends hit for lofting.
Yes.
The
Like if
USD
you
Geom.
if you take a look at the exercise, we will get to know more about it. But just try to
Mhm.
grasp as much as you can through this.
Yeah, the USD Geom model API provides a set of fields that enable previewing of payloaded content before loading. The USD Geom model API provides a set of fields that enable previewing a payload content before loading. Okay. Newer releases of OpenUSD have introduced USD Media Asset Preview API as a schema for describing asset thumbnails. Oh, so you can basically preview the properties without loading the complete file.
What?
Nothing.
Like that.
Well,
We don't know a lot about a lot of things about the APIs. So just take it,
yeah, yeah.
and then once we go through more examples, we'll get to know more.
hmm By lofting fields, you are making functionality that was previously buried deep within the payload more accessible. This involves authoring new elements above payload, creating overarching variant sets that control lower level variant sets, and defining attributes that payload connects to. Okay. Essentially, you are always introducing new fields and maintaining the accessibility of the functionality of payload. Reference to payload pattern can be used to recast payload opinion ordering strength. While the example above uses an inline payload for brevity, if a mirroring dissolver is used, it becomes important to keep the payload contents in separate layers. Hmm. Got it. In this exercise, we will add reference slash payload pattern to our asset. First, we will export the asset root layer and rename it to content.usd.
I'll be back.
Yeah.
Carry on. I'll be back. So we want to go in some water.
It's just a trailer. Trailer. Mhm. 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 Uh, okay. In Visual Studio Code, open asset structure exercise 6, create payload.py. This is just a true. Okay, create payload.py. So, first we'll export the asset root layer. Large building, not USD. Mm-hmm. So this is how we add a payload. Stage open string working directory, save as sdf.layer, contents layer name, content.usd, asset layer.export, string working directory, contents layer name, orgs format, USD. Mhm. Let's make the root layer payload the content.usd layer. Add the following code into designated part 2 section. Hmm. Can you hear my? Can you hear anything?
No, no.
Okay. Hmm. So what is this doing? Slash world. World prim is equal to USD geom dot xform dot define stage world get prim stage dot default prim world prim USD geom dot set stage meters per unit stage comma USD geom linear units centimeters USD geom dot set stage up axis. Huh. Add contents.usd as payload world prim dot get payloads dot add payload content layer name. Uh-huh. Okay, content layer name equals to content.usd. So we are creating a new USD file to store the payload over here.
Yes, I guess so.
Stage.get root layer export string working directory large building F USD args format is USDA. So I think our weakest points are primvars and variant sets. Other than that, we have pretty much understood everything else.
That's on, I guess. Like Primvars is not that complicated, but this references and payload, it's kind of confusing. But let's take a look at the example. What does this content.usd has? Open that.
Bro, like okay, wait, I'll explain to you what this is doing basically. So basically, over here we are getting the stage from this file, our large building f.usd,
Mm-hmm.
and then we are creating a new content layer name called contents.usd to store the payload in that file. So once we run this, it's going to create a payload reference over here and point it to contents.usd, I guess. And then basically this is creating a new asset layer in memory for now.
Mm-hmm.
um so what this will do exactly, set stage meters per unit, get a linear blah blah blah, create a new asset layer in memory for now. Okay, add contents.usd as a payload. So this line is adding the payload. Okay, and now, oh, that's it. Save and execute the script. Let's see what happens. Save. Save and run Python create dot payload copy path. Uh-huh. Yes. Prepend payload. So mhm. And you see over here it has created contents with sublayers. Mm-hmm.
Where is the content.usd? Over here.
Yeah.
Mm. Oh, interpolation, bitch. But where is
Constant
the variance
different.
on this? What the fuck?
We have not done variant set right now. I think that's in the other
No,
example.
but in the reference and payload, it was showcasing the variant sets, right? Or not?
No, not right
Oh,
now.
let me see. Let me see.
And you'll also see the warning in the message in the console. Yes, could not open asset at contents for payload introduced by now. This is expected because we set relative path of payload layer, which is invalid while the stage only exists in memory. What does this mean? This is expected because we set relative path for payloaded layer. Payloaded layer content.usd. Yes. Mm-hmm. Which is invalid while the stage only exists in memory. Once we save the stage to disk and reopen it, everything will compose correctly. Open the following file. Note the payload arc in the layer now. Yes, payload arc is in the layer. Okay, let's run USD view for large building F. The building X form is the root of our large building F asset. What? World building. Why is it different? World building geometry and looks. Why do we not see building over here?
Well,
There should be building inside world,
look at the
and
abstract.
the geometry and looks should be
Abstractions are
inside
not
that.
loaded.
Huh?
Abstractions. Look at the abstractions.
No, it's not an abstract class or a prim. Why would it be abstract prim?
Mhm.
The building X forms the root of wait. Unload. Something has gone wrong over here. I think we missed something.
Mhm.
Mm,
साथ साथ है. Amazon, bitch.
what Amazon?
I think bro, I was ordering a detergent and they are selling like for cheap. Yeah, $6.
What?
Amazon detergent, laundry detergent.
So
Amazon,
you ordered it.
Amazon Basics, and it's getting delivered tomorrow, right? Quick,
Mm.
best $60 spent ever.
60?
Like for the yearly subscription.
Uh, What is happening? Initiating stage on stage. Mm. What has happened? Allah ilahi. Why is it not showing building? I'm
Oh,
confused.
what's happening, man? What's happening?
We are not getting world and then building. We're directly getting geometry and looks.
Okay, first let's go back to the basics. Are we loading the correct file? First of all,
Yeah, bro, yeah.
is content.usd saved? I see a marker over there.
But it's not, we are not loading contents.usd.
And which file are we loading? Can you verify? Because I know that we have multiple. We are on exercise 6. That's correct. We have this file, and then do we have any world prim? Definitely we have world prim. And you
Wait,
know, what are we
let
not
me,
loading? What are we not loading?
let me delete this file once and then run this again. Run this script again. Create payload.py. Okay, so it has created the payload and pushed all the contents to this. And then Control C, clear, floor building F. Yeah, it's not loading the fucking building. Wait, I mean, We add the payload to default prim. I think we can create an issue. I think there's a issue with this code.
Mm-hmm.
We can create an issue if, let's see if, because I think I'm doing everything that they are doing exactly. Hmm.
Damn, son. What is the song? Damn, son. So,
Can you
what
hear the music?
is the issue we have? Basically, that our building is not loading in the file.
Yeah, the building.
Let's give it to Cloud Code and see if it figures it out or not. Let's give it to Cloud Code. Pull in the big guns.
Mm-hmm. Always be my man.
Where the fuck is my marker? Damn, son. Damn, son.
Content.usd, why is it not referencing it? Let me try one last time. I think.
Yeah. I will play this song. All and mankind.
Mm, I think Claude is also fucked. Do you want me to put this in the Discord community?
Yeah. Yeah, let's put it over there. I think they might be able to help us out. Damn son. Damn son. Damn son.
Okay. Mesh building lives here. Generic root.
What is saying the building isn't structural component prim at all. It only if it exists as a mesh name, large building are buried under blah blah blah. Wait, let me take a look. Okay, where are you seeing building? Okay, building is an X form. We do not have an X. And what? Show me the file again. Can you show me the file that we are trying to take a look? Okay, okay. Now,
This is the one.
I think I would say we do not have an X form building file first of all. And look
What?
at the name of the scene that we are trying to load over there. Like if you take a look into the example, can you go back over there and go down? What does the header says?
Oh shit. Shit. I'm loading the wrong file. My bad, bro. Crisis averted. Totally. Oh, this is the. Oh, I was trying to run large building F for some
Yeah,
reason.
I
Why?
told you earlier as well, but that's fine. All right.
C.USD. Yes, yes, yes. hmm So we see building over here, and then what do they want us to see over here? Is the root of our large building F asset, okay, which is referencing large building F, right? And it is getting a payload from contents.usd, pre-pending payloads, and then that payload is loading sublayers, shading.usda and geometry.usda, and then float 3 primbars accent color interpolation equals to constant. Okay, got it. And then what do they want us to see? Building, right click, unload. So if I do unload over here, it's gonna remove all the things from the scene. And then
Yes,
if I do load again, it is going to load everything back.
that's a payloading file. That's a payload, right?
Hmm. Right click on the building, let everything loads again. Got it. Oh, that's it. Now we are going to do lofting primvars. Okay. Exercise lofting primvars. Bro, what the fuck is this? It's so fucking long. Oh, but oh no, shit. Model kinds are too big as well. I'm bad. I'm bad. You know it. I'm bad. Who's bad? Boom, 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 boom. Oh, Exercise lofting primvars. The accent color primvar that we added in asset parameterization exercise is now hidden behind the payload. When the payload is unloaded, uh, consumers can't easily discover this asset parameter in the exercise. In this exercise, we will loft the accent color. Loft the accent color primvar above the payload so that it is still discoverable even with the payload unloaded in Visual Studio Code. Open the following file, large building UFT. Exercise 7, large building f.usd. And let's close these. Yes, sir. We can see that we have a prepend payload on contents.usd, and the contents.usd looks like this right now. It has it is referencing it is pointing to sublayers, content shading.usda and geometry.usda, and it has a primware accent color 100 interpolation constant. And then what do they want us to do? In Visual Studio Code, open the file loftparameters.py. Okay, we are opening loftparameters.py over here. And then what do they want us to do in that file? Are basically creating a directory file parent. Okay, asset layer sdf dot layer find or open. Okay, so this is going to find this file, and it's basically going to find this file as well. So both of these files are going to be found in that code snippet. And then we are going to add this code. What is this code going to do? Let's see. This code is basically prim spec equals to content layer dot get prim at path world. So content layer, okay, get prim at path world. Okay, so it's gonna wrap around this prim, and then what does it want from that? SDF dot property spec for prop spec in prim spec dot properties. Okay, prop spec in prim spec dot properties. So the what are the properties in here? X form world float 3 interpolation constant. So I think that's gonna be prim bars accent color. SDF copy spec content layer prop spec dot path asset layer prop spec dot path prim spec dot remove property prim spec property spec, and then asset layer dot save content layer dot save. Okay, and then once that is done, they want us to save the file. Okay, this code uses the SDF API, which is a bit lower level than USD API, and operates on individual layers without considering composition. Okay, operates on individual layers without considering operation composition. Here we are copying all the properties found on default prim in contents.usd and moving them in large building F. Okay, so here we're copying all the properties found in the default prim in contents.usd and moving all of them to the same prim. Specifically, we are interested in the primvar's accent color attribute so that it's discoverable even when the payload is unloaded. Save the file and execute the script. Okay, I think I got it. I don't get the for loop exactly, why how the for loop works, but I know what the code is doing. It's just fetching the property, this accent color property
Property of accent color. Okay, okay. But where is accent? Okay, accent color is over there.
over here.
Okay, okay. And layer contents is copy. Okay, we are copying the copy spec. Can you print? Let's print the property spec. Let's sorry. Let's
Wait,
print
let me
what
first
what
run
are
the
all the
file.
properties that I expect that are in there. I'll just say that.
Yeah, I will.
No, no, just put the print statement first, right? Put the print statement as well, like
Where?
about the for loop, about the for loop print spec, so that you can see what are all the properties.
Okay, Python loft parameters dot. Oh my bad. I didn't save it before. Or did it loft it already? Damn. Okay. Okay. It has sdf dot find comma slash world contents comma slash world. So this is in prim spec. I think you wanted property spec instead. So this I think sdf dot copy spec is moving the property from, like, this is the code that is performing the lofting. This is copying the thing from content.usda to large building f.usda, yes. And then this is basically removing prim spec dot remove property spec. Yes, I understand what it is doing now. Do you get it? दुनिया दे जितने रूप जितने चैन किन्ने तारे किन्ने यार किन्ने Okay, love parameters.py is done. Now they want us to open large building f.usd. नियत जिन्ने रूप किन्ने तैण किन्ने तारे किन्ने ज्ञान world Primbar's accent color. World Primbar's accent color. Yes, I can see it. Composition is root, archetype root. In USD view, right click on the world default prim, select and load. Yes, I got it.
Okay, so what was it?
You have to unload and then we can still see primware accent color.
Why? Why are we able to see the because it's still loaded in the background?
Yeah, because we have lofted it, bro. That's why.
Oh, okay,
We
okay,
have like we have surfaced it from the payload.
okay. So, but it's does it still exist in the payload or not? Can you open contents.usd?
It does not exist in payload anymore. Look at this.
Oh, okay. That's what lofting was, right? Basically, I was correct when I explained it, right? Or
Yeah,
there was something
yeah.
missing.
No, it was right.
Okay, perfect.
जितनी यादें किन्ने रूप किन्ने जाने किन्ने तारे किन्ने ज्ञान किन्ने Lofting variant sets. For this exercise, we added variant sets called exterior type to control the main exterior color. This is defined on the look scope. We will loft the variant set so that it will be accessible as a new asset parameter and make sure it is available with the payload unloaded. Mm-hmm. दुनिया थे जन्ने रूप किन्ने तैन किन्ने तारे किन्ने कैन किन्ने Git lens. Bro, do you know there is one parlay in that fight that I'm talking about
Uh-huh.
on June 12th,
Uh-huh.
where if I bet $200,
Uh-huh.
I can make $40,000 from that.
Crazy shit, brother.
Is
40,000.
$40,000.
Damn, bro, do it. $200. Yeah, do it.
Yes, Justin Gagey,
40 large.
40 large.
Yeah, that's how people
For-
say
It's,
40 large. You know how much I'm gonna bet 40 large.
it's not 40 large, but it's 40 grand.
Make search 40 large. Search
Okay, it might be 40 large too as well. I don't know.
it. It's 40 large. 40 large is 40 grand. No, 40 large slang. 40 large slang in my
Yeah, okay.
this was in Fast and Furious shit. 40 grand, 40 large. How much 40
Mm.
large?
Let's take a little break, for our audience.
For sure.
Justin Gagey. Bro, this is gonna be fucking amazing, bro.
Mm-hmm.
I'm so excited. He's the honorable one, bro. Justin Gagey, come on. Bro, even though Ilya is my favorite fighter,
Mm-hmm.
but I don't know, bro. It's just, I don't know. It might be because I'm very, I don't know. I think it's because I want to make money on this fight.
I
That's
see.
why I'm.
I see. I will ask Cloud Code and do the analysis.
Yeah, Cloud Code is gonna tell you that Ilya is gonna win.
Yeah.
No way. This guy, bro.
Damn, son.
All right, bro. Let's do it.
Mm-hmm.
Exercise lofting variance sets. Last exercise of this submodule.
Woo! Let's go. For the exercise, bitch, we added what?
We want exercise 8, large building F, and then so it's okay. For the exercise, we added variant set called exterior type to control the main exterior color. This is defined on the look scope. We will lock the variant set so that it will be accessible on the new asset parameter and make it available even when the payload is unloaded. So now we are doing not just a property, we are doing the complete variant set.
Mm-hmm.
So let's run this one first, I guess. Copy path, USD view, and then this. So here, as you can see, it's loading the whole thing. And looks, if I see on looks, we can see metadata over here. Exterior type stucco, brick. Oh, look at this. So this is metadata, looks, metadata, brick, and stucco. So these are variant types, variant sets. And if I do over here, if I do unload, it's gonna clear everything. We don't have it anymore. But if I do load again, it's gonna show me all the other things as well. Metadata tab shows a new variant set exterior type. Mm-hmm. Composition, variant. Yeah, do you see this content.usd? Archetype is variant.
Yes.
So, okay. In the metadata tab, click on exterior type variant drop down, change variant to brick. Note the building color changes. In the viewport in Visual Studio Code, open the following. So it's asking us to open this loft variant set dot py. What is the code doing? It is creating a stage from directory large building F. Okay. And then default prim is usd.prim stage.get default prim. Hard coded by convention of our asset structure, we controls the default. Prim has a lux scope. Lux prim usd.prim equals to stage.get prim at path default prim dot get path. Okay. Oh fuck. I've fucking oh honorable one. Oh shit. What the fuck? Yo, go, yo, go, go. One sec. Yeah, warrior. Hmm. Okay, so do you get what it's doing over here?
We are creating a default prim, then we are looking look prim to get the prim path. Oh yeah, we are trying to use looks, right? Looks is one of the internal tool that NVIDIA uses for defining their internal.
Hmm.
Internal type. And then we are gonna select the variants. And then what are we gonna do with those variants? We are gonna loop through them. Okay. Oh, we are defining a looks prim with a scope. Look scope. Okay, okay. Can you can you
Hmm.
can you open the output file side by side so we can take a look?
That is the output file.
Dot .py. Dot .py
What?
is the output file you're saying me.
Bro, look at the right portion.
Are you sure that is the correct file?
Yeah,
Okay, let's see. Interpolation. No, I don't think so. This is where's the looks prim over here then? I'm trying to figure out that now. Okay, looks prim is gonna be. Did you ran it? I think you did not ran it.
not yet.
Okay, you need to run it, dude. That's an old file then. Until unless you run
Bro,
it,
I know. Wha-
like
I was just fucking asking you. You fucking started reading and everything.
hmm,
Hmm. Stop moving your fucking leg or whatever that you're doing.
I'm jerking off. Jerking off USD.
Why are we not getting any viewers, bro, today?
We are doing boring shit. I'm saying you again and again.
But we are doing the same shit, but we are getting viewers before.
I don't know. People got bored.
It's a brutal industry.
Yeah, that's why, dude. Seeking attention and getting attention of people is on next level.
Hmm.
Like people go limits for their limit. Like okay, they're gonna do everything so that we can get views and all those shit.
Hmm.
But that is not our goal.
Hmm. Mhm, 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 mhm. Okay, what did it do? Mm-hmm. Mm-hmm. I've got a new subscriber.
Wow, crazy shit.
Yeah. Mhm. So you see this output?
Mm-hmm. Oh, we are gonna open load and then we're gonna do variance such as exterior type. Okay, okay, that's fine. And then now we are gonna classify the variant exterior type and its properties by using looks over looks so that we override. Okay, but looks is a class I guess that we have created. Can you scroll down? I want to take a look at the looks class that we have
Wait.
created somewhere because that's what we are overriding as.
Okay, now if I unload this, no, not this. Huh? Oh, variant type break and Stuco. Now I get it. Exterior type variant. Oh, okay. Got it.
I see.
दुनिया के कितने रूप कितने जान कितने तारे कितने चांद But why is it not working? Hmm? Oh, so if I select this to brick in the looks part, it's not doing it. Something is wrong in our code for
Mhm.
sure. Hmm. But what is wrong? Tell me, bro.
What happened? What is wrong?
Did I save it or no? ये दुनिया दे जिंदे रूप जिंदगी अड़गन तारे कितने जान Let's see. Ah, yes, sir. Yes, sir. It's working. Stucco. Yes, sir. I got it. Mm. In USD view, click on the looks. Okay, I got it. We can move if you want to.
Okay, world. In usual, click on world default from. I see. The code uses lower levels and operates on blah blah blah.
I have not seen the code though. I know what it's doing, but
Yeah,
it's
I was just reviewing the code in case anything we might have missed or something that would be critical. But yeah, let's move on to exercising lofting variant sets. For this exercise, we added a variant set called exterior type to control the main exterior color. This is defined on the lux, brother, on the lux. Oh, and we will love the variant set too. Variant set so that it will be accessible as a new asset parameter and make sure it's available even when the payload is unloaded.
hmm. She told me her name was Billie Jean as she caused the scene. Mhm. 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 Bro, what? Yo,
Yo, what happened?
what are you waiting for?
Nothing, dude. I'm already on the next one, exercising lofting variant set. I was waiting for you.
Bro, we just did this. Are you out of your fucking mind?
Yeah, bro. I was just out of my mind. Okay, so
We
then
just
let's
did
focus on the quiz then.
quiz? No, we need to complete model hierarchy,
I'm
bro.
not gonna do model hierarchy today. It's already two. If we start this, it's gonna take a lot of time then, and quiz takes a lot of time as well. I don't want to fuck up my sleep schedule completely, brother. It's already fucked up. I need to wake up in the morning. I have a meeting. I have meetings in the morning.
Just don't sleep today and then
No,
sleep
I don't
tomorrow.
want to. I don't want to do that shit. I don't want to do those kind of actions in my life now, right? But it already.
Why?
No, I don't do those kinds of things, bro. I have stopped doing those kind of shit, right? It would be better for me. I would wake up in the morning and do this rather than do it right now.
Mm-hmm.
Let's focus on the quiz.
She told me her name was Billie Jean. She caused the
Also,
scene.
the quiz is going to take at least an hour as well because we do also go and verify each and every question. So we will do again 20 questions.
Let's do 25 then.
Okay, 25. That's fine. We can do 25.
We'll do till 190. This is 165. We'll do till 190.
What do you want to do?
Okay.
Yeah, let's do 190. Okay. In OpenUSD,
Because
function attributes to store data associated with prim, such as color transform or material assignment, to optimize the rendering performance of the scene. Mm. Which of the following is valid way to create a USD attribute? B. Create attribute. Butte. Beam beam.
Not A?
No, not a create attribute is the API call that we have to use.
Yeah.
Camel case. Camel case.
Mm-hmm.
User reports that a USD stage is loading very slowly. This is they have a complex scene with many nested references and payloads. Okay, USD stages too many variant sets. The USD stage is suffering from excessive composition overhead due to deeply nested reference and payload.
But a user reported that USD stage is loading very slowly. They have complex scene with many nested references and payloads. Based on the provided information, what is the most likely root cause? Many nested references and payloads uses too many variant sets. USD stage is suffering from excessive composition overhead due to deeply nested. Maybe we USD stage has a large number of animated attribute, procedural primitives.
Large number of procedural primitives. The stage is
I will go with B.
wait. You're saying you're gonna go with B suffering excessive composition over due to deeply nested reference. The usage is large over usage contains a large using an efficient format. Procedural primitives. What is procedural primitives? And is there something kind of like that? I just want to verify that procedural primitives. Yeah, I think B looks more most appropriate over here, but I just want to verify what are such as okay, so
I don't think B looks appropriate. I think B is the answer.
okay, yeah, let's go with that. Check answer. Check. BM.
Right.
How do you
How do
apply
you
NVIDIA
apply animation on
to
crypto?
USD? Waste time. Where does it talk about time? Which this is a wrong question. I think that one.
We can use USD anim clip, right? I think
I
that's the
haven't
scheme.
seen a USD anim clip yet. I would just say that.
But we have not seen all the schema APIs yet as well. So
Yeah.
I think that could be one of
That
the
would be the
schemas.
answer, but I would just need to verify what is USD anim clip now. Oh, Gprem collection proxy Hydra stage chasing pseudo states traversal session layer prem load unload relationship listing primware over inherits anim. Okay, animated value time sample attribute. Okay, it says this anim. What the hell? Time sample, time code. Yeah, let's go with that.
Correct.
170. What is the purpose of payloads? To define material properties of a prim, to define geometric shape of a prim, to defer loading as a part until it's loaded. Needed. Which composition arc is used to include the contents of another USD file into the current scene? Override, payload, inherit reference.
Mm-hmm.
Why no? Why wasn't it payload?
Bro, payload just loads your own content that you have stored in a different file.
Oh, I see.
You want to define a custom attribute on a USD primitive that stores color value. What USD data type is most appropriate? GF-3F. Correct.
Game Studio is building a large open world game using USD. and they need to efficiently represent multiple instances of the same asset, such as tree in a forest. Which USD feature would be the most suitable? Reference.
Inheritance. Inheritance.
Mhm.
For sure, inheritance. Oh,
Instanceable, dude. That's what I was waiting for. It instanceable premise. It says efficiently, and then it's also saying they need to go up, go up. It's in the question directly. Go up. They need to efficiently represent multiple instances of the same asset, right? So if you want to represent something using instances, then you're going to use that because it's going to work on the memory buffer, and you can also verify with Gemini as well.
hmm. Correct references and instanceable prims efficiently represent multiple. No, it is right, I guess.
No, but you can still verify. That would, like, verification won't hurt anyways.
USD geom point instancer. Yeah. Hmm. So whenever we do the quiz, there's this one person who comes and then he goes.
I think that's Tiger. Tiger keeps watching us. Animated values, the data changer.
I think Tiger was streaming as well. Let's see.
Yeah. We are gonna get Tiger is our angel investor and he trades with a multi-million dollar portfolio. Guys,
Techno
please subscribe to
Wiz.
Tiger. Technoviz, Somesh, brother. Technoviz, Somesh.
There are a lot of Techno Wiz for some
Right?
reason.
Look for Somesh. Technoviz, Somesh. Yeah,
I
now
know
you're gonna find it. Yeah, there we
this
go.
guy.
Yeah.
Streamed 2 hours ago for 30 minutes.
Alright, Tiger is here. I put a research report.
Hondas.
It's Ondas, guys. Buy Ondas. I'm saying you guys buy Ondas. It's gonna shot up like crazy. Because this is Tiger Analytics research.
Yeah.
Let me see how many shares do I have for Ondas. Yes, sir. I own 110.
Hondas. Let me see if I have some.
And I'm buying it consistently. Because Tiger is saying that it can shoot up to like around.
Really?
Yeah, because that company is like gonna go like right now the valuation of company is in millions and it can do like 10x or 20x. So the stock can go at least 25, 30, something like that.
It's 13 right now, right?
Yeah. Just keep buying. Keep motherfucking buying.
Yeah, I will probably sell some stuff.
Yeah, dude, I'm gonna sell Grab, that piece of shit, for some
Bro,
reason.
for
Yeah.
real, me too.
Yeah, I'm gonna
Minus
open
80.
up Grab.
Yeah,
But
I'm
for some
gonna.
reason, you know who has invested in Grab recently?
Oh,
Perishing Square. Bill
who?
Ackman. Bill Ackman.
Bill Ackman. Yeah, that dude.
That son of a gun.
Yeah, I don't know. I have 60 shares of Grab, but they have just fucking plummeted.
Dude, you know how I have 234. Fuck me.
Clean Spark.
Clean Spark is gonna go berserk, bro. Clean Spark is gonna go crazy.
I have 25 shares.
Grab just keep on falling. Like anything else. But it's gonna go up like crazy as well. It's just matter of time. Like it's gonna take a while. Right now, the everything each and every company is focusing on AI and all those shit. That's why Clean
Mm-hmm.
Spark, dude, IBM shot up like crazy. And Trump has announced that IBM is gonna go more since now IBM has got a federal or any US government contract. Because of
Mm-hmm.
that, it's gonna shoot up more.
Mm-hmm.
Yeah.
I see. Yeah, whatever. Let's see.
Let's go back. Alright. What is the answer over here? Instanceable is equal to true. This is one of
Mm-hmm.
the critical thing for optimization. What is the primary advantage of instancing to reduce the file size to improve? I think I would go with that looks more appropriate to reduce the file size of the scene. Yeah, I would go with that. I don't know about anything else, but that is one thing that it does. But
Simplifying scene hierarchy also, bro. It also is simplify scene
instancing
hierarchy.
doesn't do that. References do that. We are talking about instancing right now, so that's my argument for not having that. Maybe I'm not correct. Only way to find out.
Yeah,
And
true.
there we go. Headshot. Let's see what Gemini says.
Memory and performance optimization. Reduced memory footprint. Keeps RAM and VRAM usage. But that is not file size, it's memory.
So where is the file size getting stored? So like, that was based on the options we had. That was my best guess. That was my argument. That okay, but the logic was the
Sure.
same. Instancing significantly reduces the memory footprint
How can you get the parent prim of a USD prim using Python?
by creating a separate file. Or we can use the get parent. Yeah, this one get parent path. Yep.
Which
We
of the following is a valid composition archetype that allows you to merge content of another USD file into the current scene without creating a new prim?
sublayer.
Wait, merge the content of another USD file.
I would say, but it says without creating a new prim. But if we use sublayers,
I think it
we
is
have
payload.
a new prim, right?
Sublayer.
Remember, like when we use when we used sublayers, we had to create a new prim so that we can load those sublayers into that prim. So sublayers won't be an answer. I'm saying now.
Let me
Give
see
me
in the code
example.
base. So over here in contents.usd, the sublayers are shading.usd and geometry.usd. So they are creating new prims. So I think the answer should be payload. No, it is sublayer. Let me check why. But it is creating new prims.
Yeah, but I don't know. Like maybe we might be missing something.
No, it is sublayer. The composition arc that allows you to merge contents of another USD file into the current scene without creating a new prim is sublayer. All other composition arcs such as references, payload, and edits virtualize operate at primitive level. Where was this, bro? We didn't even read this.
There, it was not anywhere, but
Operates.
I was just inferring through whatever hands-on experience we did, and that
Hmm.
based on that, that was my answer. That sublayer would be most appropriate. But still, I don't know. Payload was like okay. Even if we are using payload, we need to define it, right, or not?
Yeah, we need to define payload, obviously. We define a prim.
No, yeah, in the prim, like even if you're loading a payload, you need to define it in some prim, right, or not?
They require you to target a specific prim path. Oh, and link external asset or template directly to it. Wait, let me see. Hmm, the payload prepend extend variant slash content. But Sublayer is also doing that.
So I don't know. Yeah, that's the confusing part. The sublayer is only defining a prim. Wait. Oh, I know. Why? Why? Go back. Go back. I will show you now. Go back. No, like on
Oh,
the example, in our example over there. Right. Go. Open that file. Where was that file that you just opened? Yes. This is a root file.
what?
This
This
is the,
contents.
yeah. Until unless you define a root file, how will you open the prim?
This is the root file, bro.
For that contents, that is with, so for that sublayer, like it's the relative. It's relative.
Mm-hmm.
You know what I mean? So if you open contents.usd, in that contents.usd, shading.usd will be the root file for that
Mm-hmm.
for that file, right? So now, if you do not define the default prim, how will you enter it? Like this is the only point where you are not defining any prim apart from like specifically for loading it. So even if you don't put the default prim, it's still gonna load, I would guess. But since there will be no prim, it's not gonna do anything. Like we are not creating a prim
Okay.
specifically for that. I think that was the
Mm-hmm.
question mainly.
Mm-hmm. Okay. You need to create a USD scene containing a car model with multiple instances of the same wheel. Which approach is the most efficient in terms of memory usage and performance? Wheel geometry for each instance. Wheel geometry for each instance. Create a separate USD for instancer.
I think I would say instance the okay, yeah, this would be much more appropriate. USD.instancer, yeah. First two doesn't make sense, but reference the wheel geometry for each instance. We can do that or not. You need to create a USD scene containing car model with multiple instances of the same file, same wheel. Memory usage. Reference.
But it is point instancer, not instancer.
Hmm. Then it's
I don't
go
know.
V then. I would say go V. Yeah,
No, it
this is
is
wrong.
fine.
But this would be wrong. Like, can you look it up? Maybe this option is wrong. Can you look it up? What is the correct answer? Since you said only point instances, then yeah, definitely it would make sense. Yeah,
Yeah,
should you point
USD.
instance, then that option is incorrect. Yeah.
Mm-hmm. USD gem dot point instancer. Better for thousands of unselected elements like trees. Scene graph instancing is absolute production gold standard for modular mechanics asset. Like vehicle part. Okay, you are designing a USD based system for creating interactive tutorials. You need to highlight specific parts of the scene and provide instructions to the user. Which USD feature of A or API is most suitable for implementing this tutorial system? USD based system for creating interactive tutorials. Specific parts of scene and provide instruction to the user. Custom prim behavior with UI integration. I think that's the one.
Wait, you are designing a USD based
Yeah.
system. Nice. USD. Okay, okay.
What is the primary purpose of schemas in OpenUSD? To define the physical rendering properties of material, to manage version control, describe structure and content of USD data, optimize rendering performance. Yeah, A.
I think should be wait schema B. Why not B?
Version control?
B, sorry, C. My bad. C. Why not C to describe the structure and content of USD data? It should be C. Yeah, it should be C. Yeah, it's gonna be C. I don't think it's gonna be A. Schema was not first in first place was
Oh,
for
right.
design.
Yeah,
It was for the
maybe.
structure and content of yeah.
Yeah, yeah, yeah. You're right. 180.
You're designing
You're
and
designing a USD-based system for creating interactive experience. You need to implement mechanism for triggering, bro. Mechanism for triggering events based on user interaction with the scene. Which USD feature or API is most suitable for implementing this event system? This again, custom prim behavior, I guess. Yes, USD's Python API and custom prim behavior allows you for defining event triggers and actions. A game engine is integrating USD as an asset import format. The engine needs to efficiently access the animation data in the USD stage. Which of the following approaches is most efficient for accessing animation data? Import format efficiently. Which of the following approaches is the most efficient
go
for
with
accessing?
A. Wait, but game engineers you define access animation data in the user stage. Animation data or iterating if is animation. I don't know A or C. That's the option we have. Apart from it, everything is bullshit. A or C is iterating. Iteration doing iteration will be the most efficient way? I guess no. That's why I would go with A. Yeah, I think the most efficient A answer would be A.
Mm-hmm. Data directly. Use the attribute get time samples to get time samples for animated attributes. Accessing animation data, game engine integrating an asset import format, the engine efficiently. Okay. USD attribute get time samples to get okay. How do you switch between different variants within a variant set using Python?
How do no no no
This one.
no 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 no. Are you sure?
Variant set name. I think it should be A or B.
I think
I don't know if
I would go with A.
yeah, A. I don't think
No, I first of all I do not remember any set variant selection API. That's
I
why.
remember it very clearly.
Yeah, is it okay?
Yeah. Oh
Yes,
yeah, it was
it
B.
was set variant click. Okay, can you make
Wait,
sure?
let me check. Let me check. Yeah, let me check. Beyond the basics, composition basics, variant set, variant selection. I think it should be A, bro. I think that's the wrong answer. I think it should be
That's
A.
why I was saying that. But we just copy it to Gemini and we'll see.
Dot variant set object from your primitive and call it set variant selection name. Oh no, this is right. Sorry. Set variant selection and then variant name.
Okay, okay, perfect then.
Set variant selection, bro. Why did I not see it over here? Oh, this is set variant selection. My bad. I don't
But
know why, but I don't know why it has the second name.
it accepts one variant parameter. I think
Hmm.
set name. Yeah, maybe. But all right.
Is this correct? attribute error, so this is wrong.
So it's gonna take only one argument, right?
Yeah, variant set dot
Yeah.
set variant selection and then variant name. So no, this is incorrect.
Mhm.
How does OpenUSD handle scene assembly and organization? Blah 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 blah. Use a pure hierarchical scene graph and digit parent relationship. Combination of hierarchical scene referencing and composition are also flexible. Yes, I think last one.
How does OpenUSD handle scene? Yeah, that would be the most appropriate one. Bam.
Right. Hierarchical scene graph referencing and composition arcs for flexible assembly. You want to apply texture to a material in USD. Which node would you typically use to sample the texture based on UV coordinates? USD UV texture?
Wait. You
Add
want to
texture
text?
to material. Oh, shade shader. Which node would you typically use to sample the texture based?
I think it should be transform 2D.
What?
Yeah,
Transform 2D?
we have transform 2D. I think I did saw it. I might.
UNV, because UNV
Yeah.
coordinate.
Yep.
I think it could be shade shader, I guess.
Oh,
No, it is
USD view, correct. Can you verify it?
USD UV texture, that is the correct one. To sample a texture based on UV coordinates in OpenUSD, you use the standard USD UV texture shader node. This node acts as your texture sampler. It reads an input image file from disk and maps it onto your geometry by reading a texture coordinate attribute typically provided by USD primware reader. How it fits into the shading network USD primware reader.
Oh,
Hmm.
USD UV texture. Diffuse color. Okay. I see.
Which of the following is benefit of using OpenUSD schema? They automatically optimize rendering performance, they provide visual interface, they manage version control, enforce consistent data structure across different assets and tools. Correct. D. Which USD tools commonly used for inspecting and editing USD files interactively? USD view. No, not it's not used for editing.
For inspecting USD view. Yeah, USD view is the one.
No, but it's also saying and editing. We don't edit in USD view. Can we?
I don't. I think this question is wrong. Then you like the only.
USD edit. Yeah, USD edit.
What do we have a USD edit? USD edit versus USD view.
It's USD view, bro. Answer is USD view.
But for what is used for editing then? But online it says USD edit and USD view are two distinct command line tools provided by OpenUSD. Yeah, there is definitely one USD edit. USD edit is a text-based editing tool. It translates binary or compiled USD files into a human readable text format .usd and opens them in your system text editor. USD edit also exists. So it should be
I think answer is USD edit.
yeah, answer is gonna be USD edit because open USD documentation itself says it. So yeah.
Mhm.
We were using only view, that's why. Can you run USD edit once instead of USD view the way you're trying to render things? In the terminal, yeah, let's run USD edit.
I don't think it is installed.
Yeah.
Oh,
Oh, you
so you can edit this over here.
yes. So this is like more rudimentary way to do it.
Vim.
Mm-hmm.
Mm-hmm.
Well,
Control C.
yes. No, it's gonna be Vim. So you have to do colon and then yeah,
Uh,
there we go.
what does that stand for? QA.
Quit. I don't know. It's a Vim command.
Quit
Q
all. Quit all.
or something. What is the
What
purpose
is the
of
purpose of
metadata?
metadata? To define materials, apply to prim, define animation, store arbitrary data about prim.
Yeah, arbitrary data.
Yeah. Visual Effects Studio is using USD to manage complex scene assemblies. They are experiencing issues with namespace collision, multiple prims with the same name. Which of the following technique is the most effective to prevent namespace collision? Using sublayer to organize Brundes separate namespaces, different parts of the scene, prefix suffixes.
Oh, scene assemblies. Okay, scene. They are experiencing issues with namespace collisions. Multiple prims with same and which of the following technique is most effective for preventing? I think it
Different
would
parts.
be A, B, C, D, E. USD namespace management feature, prefix and suffixes.
I don't think so. That is not a. I've never seen that. I think
I
it's
have seen
gonna be
that. I have
payload.
seen that. We did saw it. Yeah, see, it's gonna be that. Go down. See, I told
No.
you. I told you it's gonna be prefix and
But
suffixes.
I just saw somewhere in the documentation that to prevent namespace collision.
You have to use naming perfectly. That was there as well, dude. And did you not saw the both the videos that I told you to watch?
Not yet.
That's
Like
why
I saw
watch
the
those
first
videos.
one.
Those videos have these critical information.
Yeah, I saw the first one.
Yeah, the watch
Like
the second one as well.
40
Because there
minutes.
is an example of showcasing why and how to use prefixes and suffixes and how do you work when you are trying to collaborate. Matty says that. A
Yeah.
USDC contains a complex animation with many attributes. You need to reduce the memory footprint of the animation data. Which of the following technique is most effective for reducing memory usage? Where is instances? Where is instances? It's gonna be B. But you said it could be A, right? It's either gonna
I
be B. Contains
I didn't say anything yet.
but I think in one of our
Yeah, this was the wrong option.
no, this was not wrong option. This was the correct option, I guess.
Lossless compression algorithm.
Yeah,
I don't know. I remember it was wrong.
you
I
remember.
think.
Then it's
Yeah.
gonna be
Some,
B. Yeah, it's gonna be B. This has complex animation.
no, it's
Oh.
neither A nor B.
Use sparse attribute storage. This is something I don't know. Just Google it up. You will see.
Using value clips, USD value clips. What is that? Alternative production techniques. Oh, USDC was right.
Well, yeah, right.
Using the USDC.
Yeah.
But
What was the answer for it and why? What is this? Can you verify like why was
answer is using value clips, USD value clips. I don't know what this is. Is this the correct answer? I think there is confusion in this question. Opus 4.8 is very slow. Okay, let's see 190 last question. Which of the following is valid use case for payloads in OpenUSD? High resolution version of an answer only when it is close to the camera, different animation sequence, different language, different material
I
assignment.
think
What?
a
Mm,
payload, high resolution camera, load unload. When it is close to camera, you can load it, and when it is further to the camera, you can do like unload it. So that's why I'm gonna go with A. That's my explanation for that. Because different animation sequence doesn't make sense. Different language version of text asset that's gonna be for variants or something else, or primvars. Different material assignments again, different thing.
different material assignments can also be payloads.
But I don't think so. Material
What?
assignments. I just don't think the material as assignments. Wait, wait. But A makes more sense regarding the use case,
Neil Patel wants to know about my schedule.
bro. Tell them.
My schedule. Mm,
First, let's answer this, and then A.
let's see.
Ooh,
Yeah,
yes,
it is.
sir. Can you just verify it once in Gemini?
I don't have any schedule, bro. I'm winging it.
All right. Another day, another.
Heavy geometric data or complex internal hierarchies. So I think the options were not correct over
But
here.
based on the options, that was the best answer. Can you do the other option that we were confused with that you were gonna go with? Yeah.
The correct answer is using sparse. Okay. Yeah, it is correct. Incorrect. My schedule. It's I don't know. Running, lifting, 9 to 5 work, and then work. Just work, I guess. Okay, we're done.
Yes, sir. All right. Let's time. Adios, guys. Peace out. What was it?
I might do some fight analysis now.
Okay, bro. Do it on new stream. That will be fight analysis. Then you will get more viewers. I would say.
I don't want to do a new stream for this shit, but I think I'll just do it over here.
Okay. All right then.
UFC Freedom 250. I
Uh,
want to make some money, bro.
make some money. Go.
I don't know if FanDuel allows login, I guess. Neil Patel, who you got? Who you got, bro? The odds on Justin is crazy. I'm on subs. Fucking 4 hours. 46. Mm-hmm. 40 inch. Uh, Dana White will win. Bro, join my stream if you wanna. We can stream together. Do you wanna join my stream, Neil Patel? Damn, then this is the wrong platform. Wait, I can send you a link. Mm-hmm. 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 30 seconds. 30 seconds delay. Damn. Probably.